The broadcast is now starting. All attendees are in listen-only mode.
Hi, my name is Alan Henley. I'm a product manager at Radiant ZMax, and I want to thank you for joining our webinar today. Radiant ZMax is the world leader in color and light measurements, and we have been providing scientific-grade measurement solutions for nearly 20 years. We are pleased to have Alyssa Wursel and Justin Reiser presenting today's webinar on Solutions for IES File Creation. This presentation will last about 25 minutes, and after the presentation, we will bring our expert panel online to have a question and answer session. At any time during the presentation, you are welcome to submit questions or comments through the questions box on the right-hand side of your display. A recording of this presentation will be available on Radiant ZMax website in about 1 week. And now I'd like to turn this over to Alyssa.
Okay, so in this webinar we're going to talk about solutions for IES file creation. I'm Alyssa Wursel, and Justin Reiser, our production manager of systems, is going to show us how to use the software later on in the webinar. So our outline for today, first we'll talk about what solutions are available. So there's conventional goniophotography, and then there's the near-field measurement system. Next, how does it work? So how a measurement is collected, specifically with the near-field system. That's what we're going to concentrate on today. What types of data can you get? So what do we mean when we say near-field data or far-field data? Then Justin will pop in and do our hardware and software demo. So we're going to work within the software and show you how to set up a measurement, what the data looks like, and how to export an IES file from the measured data. And then we'll talk a little bit about LM79 certification. And finally, we'll finish up with a question and answer session with our expert panel. With conventional goniophotography, there are two options. First, the source might be mounted on a 2-axis goniometer, which rotates in both axes and would allow the entire intensity distribution to be sampled. Or the source can be fixed with a flying mirror directing light to the sensor. In both cases, the sensor is going to be a stationary spot photometer or colorimeter placed in the far field. So in this way, we would create luminous intensity distribution measurements by combining those point measurements together. And in order to get near-field data, you would have to use a separate instrument. And we'll talk about near-field data in a little bit. So this is an image of the flying mirror goniometer. The advantages of conventional goniophotography would be that it's accurate. You do get the IES or far-field data, and it is LM79 certified. However, it can be quite expensive and is going to require a very large lab space, sometimes hundreds of feet. And then there is an increased possibility for stray light because you're sending light over such a long distance that you have to be very sure that your spot photometer down at the other end of the room is not seeing any other light sources along the way. The other option that a lot of people use would be sending your device to a testing lab. So you can reduce cost by sending your device out for testing, right? You only pay for an individual measurement, but it requires weeks to months in order to get your device back and get the data for that device. So a lot of time is spent on external testing. An alternative solution is the Near-Field Measurement System, or the NFMS, from Radiant ZMax. The advantages are that it's cost-effective, it's accurate, you get two types of data. So instead of just the far-field data, you're going to get near and far-field data, and you can still generate those IES files within a minimal lab space. So it could be as small as a couple feet, up to maybe 20 feet or so. The disadvantage is that it's not LM79 certified, and we will talk about that later in this webinar, and it's going to require an imaging colorimeter. So how does the NFMS work? We have our source mounted on a 2-axis goniometer, which rotates in both those axes, and then we point a stationary imaging colorimeter in the near field and direct it at our lit device. The device is always turned on. Normally, you can see in this video, we have overhead lights on. That's just for demonstration purposes. In general, you would want to have a dark lab space so that the only light is coming from your device under test. So we measure the luminance at all angles by taking images at each position of the goniometer. In this way, we allow the light source to not be treated as a point source. So we're not just recording the far field data, which assumes that all light is coming from the same origin. Instead, we record that spatial information. So we get luminance and color measurements, and we record them at every angle. So in general, you would get a couple hundred images that are combined together to really give you the complete characterization of a lamp. The software can then produce a model of the luminance and chromaticity as a function of angle. So we talked a lot about far field and near field. What do these really mean? Far field is luminous intensity. So it's the luminous flux in a given direction, so angular direction. By definition, a far field measurement assumes that your source is a point source. So again, all light is just coming from the same point, and it goes out in various angles. The near field measurement, however, does not assume that light is a point source. In fact, what we do is we measure light according to its spatial origin and the angle at which it's emitting. So we get the spatial and the angular data. So it is a more complete data set than far field data alone. So your traditional far field system does require that stray light control. Again, because you're sending light over a very long distance, there's a lot more room for error. It doesn't use ray tracing to get the far field data, but it gives you minimal source information, because really all you're getting is data about where the light's going, and you don't know where it's coming from. You also need that large lab area, which is going to be proportional to your device size. So if you're working on large devices, it could get quite huge. The near field system, on the other hand, requires very little space. You don't need a tunnel to block out stray light. Just a standard dark room will work. Data can be used in ray tracing software to accurately describe the illuminance distribution at any distance. So rather than just at an infinite distance away from the source, you can actually see the illuminance pattern at any arbitrary distance from the source. Perhaps you wanted to see, a meter away from a device. You could test that as well as 5 meters away and see how the distribution changes. And you also get luminance data, so we can actually directly measure glare from your light source as well. So the NFMS measures the near field data. It gives you more information than your far field only techniques because it doesn't treat your light source as a point. It takes into account that spatial information of where your light is originating, and it can predict the illumination pattern at any distance from the source. So in essence, far field data is just it's the illumination pattern infinitely far from your source. So by measuring the near field data, we're able to get both the spatial and angular distributions. So we get both that spatial data that you need for modeling close up and the angular data that you need for IES files. The frame of the NFMS is designed to hold large or small luminaires, so it can do either one up to about 4 or 5 feet, depending on your device shape and size. And again, we can produce that near and far field models in just one scan. So you don't need multiple devices, just all at once with the same measurement, with the same data set. The resulting data consists of luminance measurements. You can get chromaticity according to its spatial location, luminous intensity. We can calculate the illuminance at any given distance, see the near field distribution of light, as well as that far field distribution, so ray tracing out to infinity. And if you add on a spectrometer, you can also see the spectral data according to angle. You can also see the view angle performance. So that's the major benefit of that angular data or that far field data. You can see how the performance of your light source changes as you're looking at it from different angles. And finally, you can output data in a variety of formats. You can make IES files, LDT files or illum.dot files, and radiant source model output formats. So with the radiant source models, you can actually export ray sets that can be used in optical modeling software programs such as ZMAX or a variety of others as well. And this is just an example of what we had talked about with the with seeing the illumination distribution at any arbitrary distance from the source. So if you wanted to, for example, simulate the illumination of a light that's placed under your countertop, you can do it with a near field measurement. You wouldn't be able to do this accurately with an IES file because the IES file can only predict what's going to happen very far away from your light source. But in the case of cabinet lighting, you're not working very far away from your source, and the spatial extent of that source is going to matter in the illumination pattern that's created. So how does the NFMS compare to conventional Gaussian photometry? It is a complete data set, so all of the image data is retained for further analysis. You get hundreds of photos of your source that are all calibrated to measure light and color. You get a more extensive data set. You get the spatial and angular data of your source, so you can create ray sets or IES files. It's cost effective. You get fast results, so there's no waiting turnaround time. You can get results just in-house within a day or less. And you can use the camera for other measurements as well. So the camera isn't fixed to the NFMS system. You could measure displays, you can measure illuminance patterns with that camera as well. And it is very accurate. So we've proven that the NFMS is within 1% of reference measurements. So within 1% of conventional Gaussian photometry as well. So now we're going to turn over to Justin Reiser, who's going to show us a little bit about the software. He's going to show how to set up a measurement and then do some analysis of the data and export an IES file.
Okay, so we have aligned our camera in front of the NFMS, making sure that the height of the camera and the offset from a known reference such as the wall have been verified. We've also optically aligned the system so that the camera's center optical axis and the center of rotation is well defined. We have also taken care to focus the camera and adjust the exposure time. So now we're ready to go down the checklist and verify that all of the software settings are correct. We have entered in the source information and the camera distance. Camera distance is listed as 1.4 meters. The source type is an LED module. Model number is 147 alpha. Serial number is 5281. And this is manufacturer unknown, so we will just put that in here. Scan environments allow you to enter parameters as the humidity and temperature. We have selected a measurement setup, color 1x1 binning, for which we will be taking photopic measurements today. Verify the lens setting. We can trust that the Canon software-controlled lenses are set correctly. We've already performed the alignment and the field of view scaling. We've mounted the power, making sure we have mounted the source, making sure to route the power through the system in such a way that the cables will not hang up on any of the rotating bits. We have also verified there's no motion restriction by moving the NFMS to its full frame range of motion. We've refined the source alignment, and if you follow any one of these blue checklist items with a right-click function, they'll take you to the appropriate software function here, in this case the Active Align window, where you can see that we have aligned properly to the source. Okay, moving on, we've allowed the source to warm up. In this case, we've waited approximately 15 to 20 minutes. We can record the source power settings for future reference. Next, we'll turn off the ambient light source, so the only sources of light that we're measuring are from our source under test. We've set our exposure times once before, but we might as well check those again. Here, adjusting the green filter to 70 milliseconds, reaching a healthy 75% of saturation. That's perfect with what we want to see. We'll go ahead and save that. Next, we'll verify our subframe region. This allows us to apply a static crop. If we know that we are measuring a source that's smaller than our field of view, we can crop down to a more appropriate size. This allows us to only save the data that we actually need. That's very similar to step 15, which is the luminance crop. The luminance crop allows us to apply an image crop and a threshold to the image that's based on a percentage of the maximum gray values measured. I always find that it's useful to use a crop of somewhere around 0.2%. Again, that's 0.2% of maximum. That allows us to really crop down and only record the data from the light source, the light that's coming from the light source to the database. And in that way, we avoid capturing stray light sources. Step 16 is perform a brightness scaling or a color calibration. We will be using the factory supplied color calibration today. And then finally, step 17 is to perform scan. Right-clicking there brings up the scan control. So now that we have the scan control brought up, we have defined our range for measurements and inclination to be from 0 to 90 degrees in 10-degree increments. And in azimuth, the full range of motion, 0 to 360 degrees in 15-degree increments. That gives us a total number of measurements of 179 pending. We'll apply those measurements to the queue and start to scan. Okay, now that our scan is complete, we can use NFMS to check and make sure that everything looks good. Let's check the near field intensity, which looks very symmetrical. This is a very Lambertian type emitter. We do have some eccentricity here caused by the fact that the source that we're looking at is rectangular, not square. Okay. But what we really want to look at is the IES file. So for that, we will actually close NFMS and open up ProSource. So here we have our file opened in ProSource, and to generate the IES file, we first need to have an intensity radar plot traced to infinity. You do that by clicking on the Generate Far Field Intensity Plot and selecting the number of rays you'd like to use for the generation. We'll use 10 million. Okay, now that we have successfully generated a far field intensity plot, we can use this to generate an IES file. We can choose to use the preset defaults for parameters such as inclination angle increment or azimuth angle increment, or you can increment them a degree at a time. We'll just use the defaults. You can select the intensity plot to use. Here we'll use the one we just generated, or we can generate new. You can also choose to use the intensity as measured data. Click the Generate button, and we'll save this as Husky Work Lamp. Yes, I want to replace. All right, now that that's done, we can open the file in an IES viewer. As you can see, the file has a nice symmetrical distribution, just like we'd expect.
Okay, so who can really benefit from an NFMS? Anyone who needs to characterize the view angle performance of an emitting device. In this case, we talk a lot about luminaires, but it can really be any light emitting device at all. So with the data that you're going to get from the NFMS, you can do near and far field intensity distributions, which is helpful if you're going to be doing software modeling, or if you need to give data to lighting designers who will then use it in software. We can do the illumination distribution for large light sources, and as well these files can be used again for architectural lighting systems or designing the lighting within a room. So again, very important within the lighting community is the IES and LDT file formats. IES being a US standard and LDT being a European standard. They both contain that far field data set which you're going to get from the NFMS. Now what about LM79? We had talked about it at the very beginning of the webinar. And said that the NFMS is not LM79 certified. Well, that's because the source is not aligned as it would be used with respect to gravity. So the light source when mounted on the NFMS goniometer is not oriented the same as it would be when it's plugged into your ceiling or plugged into your socket. But we've actually shown that very little difference exists between the output of a lamp aligned in one orientation versus another. So the output of your light and where the light is going to go is not really going to change. So you won't be able to certify your own LM79 certification, but in general you wouldn't self-certify anyway. What you can do is you can create those IES files that are going to be just as accurate as sending it out for someone else to certify your lamp and measure that IES file. And you'll be able to verify that your lamp source is going to pass LM79 before you send it out for testing, which can save a lot of time and money. The NFMS is not intended to be a certification system. So again, that value lies in pre-certification testing. It's going to save you time and cost by making sure that what you send out is going to pass, rather than having to send out multiple iterations and paying for testing on each one of those iterations. So that concludes our webinar. We are going to have a question and answer session, which will be hosted by Alan Henley, myself, Alyssa Wursel, Justin Reiser, our production manager of systems, and Leah Selstead, our senior applications engineers. You should be able to enter questions into the little box, the little text box on your screen, and we'll be able to see those questions. We'll read them out and then provide answers during this Q&A session. If you're unable to attend our Q&A or you don't have time to stick around, thank you very much for your attendance. And if you have any questions, please don't hesitate to contact us. The best way to reach us would be to simply email support@radiantzmax.com. Thank you very much.
Okay, well, thank you, Alyssa and Justin. We have a few questions that have been queued up here, and if people have some more, please enter them into the box that is, there's a question box on the right-hand side of the screen there. One of the questions was around exporting some of these ray sets. Maybe Leah. The question is which software tools can this export to? Which, design softwares can it export to?
Sure. So optical design software that we can export to includes ZMAX, of course, and also Light Tool, Trace Pro, Speos, Fred, ASAP. We also have generic formats, generic binary and ASCII formats. So pretty wide range. That shouldn't be a problem if you have some special requirements. I'm sure we can figure something out.
Great. Thanks, Leah. Another one up here, maybe I'll give this one to Justin. Justin, this question is, what is the maximum weight of the luminaire that can be held? So we know exactly what that is?
Yeah, I believe it's somewhere around 25 kilograms for the NFMS 800. The NFMS 400 is a little bit smaller. We recommend sticking to a 5 kilogram source on that.
So we actually have two different models of NFMS goniometer, the 400 and the 800, and the limits on those are 5 kilograms and 25 kilograms, I think is what I just heard. Okay, great, thanks. One question was about, I'll answer this one. One question was about our recently introduced Prometric G camera colorimeter. Is it supported with the NFMS system? The answer is yes. Just recently, within about the past 30 days, we did release the new software, the NFMS application software that supports the Prometric G. The benefits of the Prometric G, the lenses are calibrated over a wide range of working distances. So you can, I guess, use it at different distances from the NFMS system. And then also the LCD screen on the Prometric G simplifies the alignment. So one of the first steps in a measurement is to align your colorimeter with the device you're testing. And the Prometric G has some convenient features for that. Another question here. When you measure the near field with a colorimeter, what parameters are measured? I think we're talking about luminance and color here. Looking for a nod from who? I think Leah wants to answer that one. They're fighting over who's going to answer the question on this end.
Sure. So the parameters that are actually measured are luminance and color. And then we use that database of luminance and color measurements to interpolate and sample into an intensity distribution. So in the end, you get the near field distribution of near field and far field distribution of intensity and color.
So what units, for example, would we be measuring in?
So the end product is in candela. The original camera measurements, the database of measurements, are in candela per meter squared, which is luminance. Color can be measured, so it's chromaticity. So we measured using tri-stimulus filters, and the color values are output in chromaticity coordinates like CX and CY or U prime, V prime, or correlated color temperature.
Okay. So one of the questions was, I think we somewhat answered this. One of the questions was, is the NFMS limited to photopic measurements? And so the answer on that definitely is no. We also do color measurements and spectral measurements with a spectrometer.
That's right. Yeah, using the Radiant ZMAX SP1000 integrated spectrometer, we're able to capture the spectral data with view angle.
There is one question about the cost of the system. So the system's available in a variety of different configurations. Simple photopic systems for small devices up to complete systems with large luminaires, color, and spectral data. So really to give a reasonable estimate on what a system would cost for your needs, really need to sit down with people and decide what is their specific needs, and we can build a system for you. We can figure out what a system would cost. This one I do not know if we have an answer on, but I'll go ahead. Somebody has an Everfine spectroradiometer, and can your software be helpful to generate the IES file? I'm not even quite sure I understand that. Is anybody?
I'll take that one, Alan. So the NFMS value out here for helping to generate the IES file would be to capture the intensity distribution of the light source. That's really what you're going to use to get that IES file. You could use your Everfine spectrometer to help calibrate the system to your source under test, so that your measurements and your results from NFMS correlate with your other lab measurements.
Okay, thanks, Justin. I think that is the end of the questions that we have submitted. There's the ones we're willing to answer. And so we'll give folks about a minute. If they have some last-minute thoughts and want to enter questions, we'll hang out here.
Okay, so a question came in from glare. The way that we measure glare is by referring back to those luminance images, and that's part of the added information that you get with the near field data.
We do make some assumptions about a standard observer in order to calculate that glare. So we've produced our own algorithm with some assumptions, and then we end up calculating glare for each angle that the camera measures.
Okay. Question here, the method to verify the IES file generated by ProSource is available to the optical design softwares. I think that's the same question we talked about a little bit sooner. Leah, can you rattle off again which one of the optical design softwares that we know of?
Sure. So quite a wide range, including ZMAX, of course, and Light Tools, Trace Pro, Speos, Fred, ASAP, and also generic ASCII and binary formats.
So that would be for the ray set.
Correct.
And then the IES file itself can be used in any ray tracing program or rendering program that can use an IES file format.
There's a question from someone about can they send devices into Radiant ZMAX and have us do measurements for them? The answer on this is yes. We do have measurement services for people that do have truly the occasional need. Of course, we believe there's a lot of benefits of having your own system with faster turnaround and helping you improve your design. And they truly are relatively small systems that fit into a reasonable sized darkroom. So, but yes, we do offer that as a service, so please contact us if that's of interest. Okay, we're somewhat winding down on the questions. I want to thank people. This will be available online on our website. We have a resource center where webinars can be downloaded and viewed later. It takes us about a week get this put up on the website, but you are certainly welcome to log back in. I think we asked for some email information, and you can view the webinar online. So thank you, Leah, Justin, and Alyssa. It was a good job from everybody. And another question came in. Are you planning a webinar on BSDF characterization? We'll take that into consideration.
We have one that kind of relates to BSDF measurements, and it's on our website. If you want a link or more information to that webinar, please just email our support address and we can send it to you.
Okay.
There's also a question here about if the IES file or the RaySet radiant source model can contain the spectral data, and they can, especially if you're using the optional spectrometer to take those measurements.
Right, so the RSM itself can include spectral data for each angle. I don't believe IES files include color information.
Right.
Great. Okay, thanks everyone for joining us. And yeah, please reach out to us if you have some additional questions, or we can help look at a specific system for you.